Hey ladies and gentlemen, today we're going to be talking about how to solve common problems that you see in geometry about measuring angles and segments. So let's go ahead and let's get started. What you're actually going to want to do first is make sure you're familiar with some terms such as points, what a line is, what a plane is, basically how we note them pretty much. But more importantly, I think you're going to become familiar with how we denote a line segment. So how do we refer to a line segment? For example, here's an example of a line segment AB. Most of the time, if I want to refer back to that, I'll write this. It's AB with a line over it. That means line segment AB. The other one notation that I'll be using today will be how to refer to an angle. So in the questions, they usually refer to angles different ways. So they could, for example, on this angle, talking about this one right here, there's different things that I can call this angle. I can call it angle Q, okay, because there's a Q right on the outside. I can call it angle PQR, which the way they get that is they simply just follow those points. So if I follow those points, if I start at P, go to Q, and then to R, angle PQR is going to be the angle formed inside of those lines. The other way I can refer to that angle is if there's a number on the inside, I can simply just call out that number and say angle 2. Okay, so let's go ahead and get started on some of the common problems that we see usually about measuring line segments and angles. So here's one. It says, refer to the figure shown. How can you find the length of AC? So we're looking at this figure. The first thing we want to do is they're talking about line segment AC. So let's go ahead and make sure we know what line segment that is. So I'm going to draw a point on A, I'm going to draw a point on C, and I'm going to connect those. This and this will be line segment AC. Now the easiest way for you guys to do this is going to be just go ahead and count the spaces in between. So this is 1, 2, 3, 4. So 1, 2, 3, 4. So I know that the length of AC is actually equal to 4. And that's it. That's a pretty common one, pretty easy. But this next one, you're going to be a little bit more careful. So let's go ahead and let's move on to the next example. So again, they could have asked me about any segment here. CD would have also, they could have asked me what's the length of CD, which would have been this one in red. Again, I would have just counted 1, 2, 3. So segment CD would have equaled 3. That's just the easiest way to go ahead and answer that one. Now this next question, okay, they bring in a little bit of algebra. So what we're going to want to do is these points are all lining on the same line. We call that collinear. Points J, K, and L are collinear. That just means they're on the same line. Now what they tell us is they say if JL, so if this long segment right here, if this segment has the length of 25, okay, it wants to know what is N. Okay, so if this segment has a length of 25, what is the value of that variable? So what we do based on this image, okay, I know that the whole length of JL is equal to, so that same length can be broken up into two parts, segment JK and segment KL. So JK and KL. So if I wanted to write this in sort of an equation in a formula, I could say that JL, the segment, is equal to segment JK plus KL. That's how I build a formula for this equation. So the whole line is equal to the smaller segments. So the whole segment is equal to the smaller segments that are inside of them added together. And actually can replace some of this stuff. So I know the length of JL is 25. So I know 25 equals. Now JK, what is the length of JK? Based on this equation, it's 3n. And then KL, similarly, is 5n minus 7. So this is going to be plus 5n minus 7. now I need to use some algebra skills to go ahead and solve what n equals. The first thing I'm going to do is I'm going to combine like terms. I see that I have two terms that have, so 25 is going to equal, I see these two terms can combine. 5n plus 3n is 8n. This negative 7 is going to stay the same. And now this becomes a two-step equation. So I'm going to go ahead and I'm going to rewrite this out here on the side. And I'm going to go ahead and flip the equation over just because I'm more comfortable with that. So I'm going to do 8n minus 7 equals 25. All I've done is flip the equation. I didn't change anything else. You're allowed to do this. So the first thing I would do is I would add 7 to both sides. They would cancel out on the left, leaving me with 8n equals 25 plus 7. That's 32. Then I would simply just divide by 8. (32) divided by 8 gets me n. So now I've gotten n singled out on one side. 32 divided by 8 is 4. So I have now found that n equals 4, which means I've solved the problem. What is n? N equals 4. And a common thing to do next in these problems like this is that they'll ask you to use that value that you just found. So now that we know that n is 4, we can actually find jk and kl, which is what the next question asks. It says, what is jk and what is kl? So again, referring back to the diagram, I know that jk equals 3n and kl equals 5n minus 7. I can substitute that 4 into this, so I'll do one at a time. jk is 3 times n, which means it is 3 times 4, since n equals 4, which equals 12, meaning jk equals 12. So that would be the answer for jk. Now let's solve for kl. kl is going to be 5. Again, n is 4, so I'm going to substitute 4 in the place of n. And I have minus 7. So this would equal 5 times 4, that is 20, minus 7. So 20 minus 7, that would be 13. So I know KL equals 13. And this is how we solve this problem. Okay, again, if you need to rewatch this problem, go ahead by all means. I know it might have been a little fast, so if you need to rewind and re-see a few parts, if you have any questions, again, ask me in the comments or in class. This next question, another common question, is how to find a certain angle. So usually what I like to do is I'll read the question and then I'll go back and I'll sort of highlight the important pieces. So this reads, if the measurement of angle QOS equals 56. So in geometry, you have to really learn what the terms mean, because when you read the problem out, you have to make sure you understand what it's saying. So again, these mean the measurement of angle. So this is saying the measurement of angle POR is 65. And the measurement of angle POQ is 26. They want to know, what is the measurement of ROS? So let's go ahead and let's go back and label these so that we can start making sense of them. So they're saying, if the measurement of QOS is 56, let's go ahead and look at the diagram and actually draw that out. So QOS, that is going to be right here. So they're saying if this angle QOS, sorry, it's a crooked line. If angle QOS, so if this angle right here is 56. Okay, so that's not too bad. We know what that means. We can see it now. I'm gonna go ahead and erase the lines. So they're saying if that angle is 56, and if angle POR, so let's go ahead and highlight that one. So if angle POR, so this is a bigger angle. They're saying if this angle, right there, it's a pretty big angle, is 65. Okay. And so they give us another angle, the angle POQ, so POQ, so this smaller angle on the inside. They're saying if this angle is 26, again, I'm going to erase the lines for the other angles. So saying if that angle is 26, then what is the angle of ROS? So what they are looking for is what is the measurement of this angle, ROS. This is what we're trying to solve. What is that angle? Okay. So there's no clear way in how to solve for this right away off the bat. So we have to find out, how can I find this distance? How do I know what this angle measures? So what we do in this problem, the way we're going to solve this one is this. We know that if we can find this piece right here, if I can find out the measurement of this angle, then it'll help me find this one. The reason why is because this whole angle is 56. This one right here is 56. So if I can find this piece in the inside, I can do 56 minus this amount, and that'll leave me left over with whatever this is. Okay. So the question becomes, how can I find this piece first? Well, there's actually a way to figure that piece out. This is an angle that we don't know. Okay, we do not know the length of this angle right here. But there's a way to figure it out. Because we know that this whole length, going from POR, we know this length is 65. And we know that this length is 26. So if I do 65 minus 26, that should get me this inner part. So 65 minus 26 equals, okay, if you do the math correctly, you should get 39. So now I know that this angle right here is 39. Okay. And that's important. So I'm going to go ahead and erase the work that showed me how I got that angle. So now I know that, we'll do this in highlighter, this angle right here is 39. I'm going to use that because now that I know that this whole length, I know that that is 56. And I know that this part is 39. So now if I do 56 minus 39, it should give me the angle that I'm supposed to solve for. So meaning this angle in the inside is 56 minus 39, which if you do that correctly, you should get 16. So this angle right here, 16. Okay, it's a lot of work, for one problem, but like I said in the previous problem, if you need to rewatch this, go ahead and rewatch this. So I know that angle ROS is equal to 16. And the reason I found that was because 56 minus 39 equaled 16. Okay, so that would be my final answer in this case. All right, so let's go ahead and let's keep moving. Another type of problem that they do has to do with congruency. So let's talk a little bit about congruency in math. Congruency in math means, in geometry, means that two things are equal. And the way they usually note it is by showing you lines like this. So for example, these two marks right here are telling me that segment AB and CD are the same exact length. Another way they can show it is by using this symbol, which is the congruency symbol. It's like an equal sign with a swirly line on top. Now, if you have multiple lines that are congruent in the same image or diagram, the way they distinguish the two is usually by you add one line to talk about two segments being congruent. If there's another pair of segments that are also congruent, you add an extra line. So I know that these two are also congruent. So that means that they're equal in distance, but it doesn't mean that they're congruent. It doesn't mean that these four are all the same length. So in order for them to be congruent, they have to have this red line, but they also have to have the same amount of red lines. So these two are congruent and these two are congruent. The same thing's true with angles, except with angles, we do a curved line inside the angle. So again, same rules apply where these two are going to be congruent to each other, meaning they're the same exact measurement. And these two are going to be also congruent to each other. Again, these have the same exact number of red lines. So these two are congruent to each other. These two right here, but they are not congruent to the ones above them. So they have to have the same amount of red lines in order to be congruent. The same number of arc marks is what we call them. So we use this to help us in solving problems. Okay, so here's another common problem. All right, they give you a diagram with a bunch of congruency marks, and usually using those congruency marks, you find out the length of certain segments, and you use that to find the length of the segment that they're asking for. So let's go ahead and read this problem, and then we'll find the information that we want to eliminate. So let's go ahead and read. The problem reads, suppose EG equals 4, EB equals 11, AF equals 10, and that the angle EBG is 21, angle EGF is 31, and angle CAE is 50. They say find AD. So our goal is to find, this question really wants to know what is the length of AD. So normally when I get a problem or a question like this, the first thing I try to do is I looked into the information and I try to rule out anything that I do not need. Most of the time, if they're asking for the length of a segment, that usually means that I do not need to know the information about the angles, at least for now, at this level of question. And the same works the opposite. If they're asking me a question about an angle, I'm going to ignore the line segments, but that's not the case here. So now I know just to focus on these, okay? And I try to label these. So let's go ahead and see. Angle E, or segment EG, is equal to 4. So this segment right here, EG, has the length of 4. That's what I know so far. Now, based on what we just learned about congruency, any other line that has one vertical line like that also has the length of 4. So that would tell me EF also has the length of 4, and DF also has the length of 4. Any line that's blue on there, so this has the length of 4 and this has the length of 4, based on congruency. That's what we just learned. If they have all those lines have that one perpendicular red line going through them, then they all have the same length. So if EG is 4, that means the other two lines that have those red lines, the red tick marks, they're also going to be 4. Let's see what they say about EB. So EB this line with 2 tick marks is the length of 11. So that means any other line in here that has 2 tick marks is also 11, which I see one more, which is angle AE, or line segment AE, that has a length of 11. So now the last piece they give me is AF. They say AF has the length of 10. So from point A to point F, this distance right here is 10. Okay, and we want to know what is AD. So already, based on what we've learned on congruency, I can see 2 pieces of information that are going to help me find AD. Okay, AD is inside of the line AF. Okay, so I know the whole length of AF. And just like we did a few problems ago, I can say that AF is equal to AD plus the line that comes after AD, which is DF. Okay, I'm just looking at this piece right here. And I actually know the length of 2 of these 3. AF was 10. Which is equal to AD. And I know that DF, based on the congruency rules that we learned, has to be the length of 4. So based on this equation, I can actually solve for AD. It's a simple one-step equation now where all I have to do is subtract 4 from both sides. And I find out that AD actually has the length of 6, because 10 minus 4 is 6. So now I know that AD equals 6. And this is how we use congruency to help us solve these problems. Usually when I'm labeling out my lines, I go ahead and match all the other lines that are congruent. So when I labeled EG over here, labeling all the other lines that were the same length as EG based on congruency helped me to solve this problem in the end, and helped me made it easier for me to see the connection. As always, if you have any comments, questions, would like more examples, feel free to let me know. I hope this was helpful to some extent. Like I said, if you need to rewatch it, go ahead and rewind, rewatch it, go at your own pace, really. And then I'm more than happy to help you guys. Thanks for watching. Like I said, I hope this was helpful, and stay tuned for the next videos. But yeah, till next time.